we will try to discuss single phase induction motors. Okay, the separate unit single phase induction motor. You might have already known three phase induction motors. Okay, now you might have discussed or you might have known the basics of the three phase induction motor. What is three phase induction motor? In three phase induction motor, we'll try to connect three phase supply. Okay, we'll try to connect three phase supply. And what about here? Basically, it's a motor. What is a motor? Which converts electrical energy into mechanical energy. Basically, it converts electrical energy into mechanical energy. So this motor, okay, it converts electrical energy into mechanical energy. Here, whereas normally in three-phase induction motor, we will give three-phase supply. Directly, three-phase supply is abundantly available. But coming to in our homes, okay, now and other things, what actually happens here? We will use a single-phase supply in our household appliances. Okay, now for all our household requirements, we will use only single phase. Where we use three-phase here, for industrial requirements, we will use three-phase supply. So when we use single phase supply in our homes, now if I bring any three-phase motor into our home, and if I want you to use that, will that be possible for me? No, it won't be possible, because so for grinding or for washing machine or for any water lifting, so all this require mechanical work. Definitely we need a motor. So that motor has to be what is available with us. Okay, now the supply which is has to be available with us here. So there, what in our houses, okay, now we have the single phase supply available with us. So that it's more important to connect or go with the single phase induction motor. It's more important to connect or go with the single phase induction motor. Is that okay or not? So what is the importance of single phase induction motor? Directly single phase supply is available, and with the usage of single phase supply as an input, we will try to convert that electrical energy into mechanical energy, and we will try to use that as per our convenience. Okay, let it be the grinder, mixer or washing machine. Okay, now all this requires some single phase motors, and even there are separate specific and coming to the advantages here. So I don't want to get into the complete basics here. So I'll try to discuss the major things so that it will be easy, and you can go through the remaining basics on your own here. So why it is more advantageous here? Because it's single phase supply is directly available, so that we can directly make use of our requirement. Okay, even the small half HP motor or 0.25 HP motor, we can convert as per our requirement. Okay, and coming to that, where we use this here, we'll use here in vacuum cleaners, washing machines, centrifugal pumps, blowers, washing machines, and all the places we'll try to use that. Each machine has separate its own limit. Okay, we'll try to use one machine to vacuum cleaners as well as washing machines. Some other machines will be applied for the both here. So I will try to discuss what are those types of single phase machines. Basically, by using single phase supply, we will try to categorize into two types here. One is single phase induction, induction motors, as well as there is one more topic is special motors, special purpose motors here. Okay, special purpose motors here. This is single phase induction motor is nothing, it comes under the category of induction motor family here. What are the concepts of induction motor is there here? How the induction motor works here? In the same concept, the single phase induction motor will also works here. Okay, whereas special motors here, each machine has its own characteristics, like stepper motor, okay, hysteresis motor, a universal motor. Okay, that machine has separate principle of operation, separate characteristics for its operation. Is that okay or not? Okay, so coming to the construction here, it is same as that of the single three-phase induction motor. Okay, now stationary part. Okay, stationary part is same as that of the three-phase induction motor here. And here, once we say that laminations, what do you mean by laminations? I guess, please help me in. If you already know the things, it will be better in discussing, and let's not waste my time as well as your time. Okay, now laminations are instead of taking a single iron core here, what I'm trying to do here, I'll try to use 1,000 pieces of sheets here, and I'll try to join all the 1,000 sheets in a single bolt by using the bolts and nuts here, and in between I'll try to place the impregnated paper, okay, now, or else some insulated paper here. So what happens here? There is no path is provided for the current to flow from the one sheet to the other sheet. So basically, a circulating currents will be generated within the any core here. So that losses leads to eddy current losses. Eddy current losses is nothing but the circulating current losses. Whenever currents there are here, I square R losses will be generated. That circulating currents leads to eddy current losses here. Now, how to reduce this eddy current losses here? Reduce the laminations. Okay, by incorporating the laminations here, we can able to reduce the eddy current losses. If you see, even in any machine, this laminations will be there here. Ultimately, eddy current loss and iron hysteresis losses, both are the iron losses. Okay, in order to reduce the iron losses, we should be able to do the laminations. Okay, is this speed is okay? The concept which you already know, I'll try to be a little bit fast. The other things I'll try to be slow. Is that okay or not? Please respond. Yes or no? Okay, yeah. So here, what we'll do here, why we place slots? What is the purpose of slots here? Purpose of the slots is to accommodate winding. So purpose of the slots is to accommodate the winding here. It's accommodate the winding here. Okay. So same silicon. Okay. How to reduce the hysteresis losses? So hysteresis losses, we have a hysteresis loop here, BH curve. Okay. So magnetic field intensity here, BH curve is there here. Okay. This by reducing the hysteresis loop here. Okay. We'll see that by using this better suitable material, we can able to reduce the hysteresis losses here. What is the suitable material? Silicon, steel here. Okay. So B max to the power of 1.6 here. So this is basically comes under construction. Whenever we discuss about construction, we need to discuss about the laminations as well as this hysteresis losses. And coming to the rotor here, the rotor is a rotating part here. It connects to the rotor is you can see that. Yeah. This is the complete constructional diagram here. The outside this one is stator and this one is rotor. Okay. And here the stator, we have the slots. There is some keywords. We can say that the slots are inner periphery. What does it mean here? The slots are showing projecting inwards. The slots are projecting inwards. We should be able to write down this word here. It is inner periphery. Whereas in rotor we have to specify that it is outer periphery. Always rotor, the slots are outer periphery here. Okay. So we'll try to accommodate the winding here. We'll try to see that 1/3. Okay, it has slots on over it periphery. The slots are not merely parallel. So everything is relevant to this three-phase induction motor. I guess there is no need to repeat again and again about this terms relevant to the three-phase induction motor. What is skewing here? So skewing is nothing but let me try to tell you in short. Okay, as a revision here. So the rotor slots. Okay, the bars, copper bars are not kept in parallel with respect to this shaft. Okay, now it is slightly tilted with respect to the shaft, so that here this humming noise can be reduced here. This is skewing here. Okay, magnetic locking tendency will also be magnetic. In order to avoid the magnetic locking tendency, we'll try to use this here. Okay, and major advantage is nothing but even we can go with even the small scale applications. Even for the small ratings also, we can able to go with this single phase motors here. Okay, so that too specifically in single phase motors, we'll try to go with the single phase. So actually we have single phase motors. In that I'm trying to separately discuss here single phase induction motors. I'm trying to separately discuss single phase induction motor. Is that okay or not? Okay, single phase induction motor. Okay, this is all the basic thing here. So what I can say that here we'll try to connect with supply, single phase supply. I'll try to connect one phase as well as one neutral to this single phase supply. Whenever a supply is connected, single phase supply is connected to the which part? Stator. Okay, a field is generated here. Okay, flux generated. Okay, this is the rotating flux or not? Okay, rotating flux here. Let me try to add a few more the basics here. Okay, so here I'll okay, I hope you can able to see this. For three-phase supply, we have this for a three-phase motor. Normally, what is torque here? Torque is nothing but turning or twisting movement about a particular axis is nothing but torque here. So in terms of we'll say that so torque is nothing but force into perpendicular distance here. Okay, if you see a fan here, the fan is rotating with respect to a particular axis. That we can call it as torque here. Yes or no? Now, how the mechanical energy is generated here? Because of the torque, the mechanical energy is generated here. We would like to see that in any motor, the torque has to be generated here. So let me try to tell you a generalized expression. Okay, so torque is always, I'll try to make a correlate in terms of a simple formula here. Torque is proportional to phi 1, phi 2 sine alpha. Torque is proportional to phi 1, phi 2 sine alpha. What is phi 1 here? Phi 1 and phi 2 are two different fluxes here. Okay, flux, two different fluxes, flux 1 and flux 2 here. So, and what is this alpha here? Alpha is nothing but phase shift between phi 1 and phi 2, or I1 and I2. So it is a phase angle between the phi 1 and phi 2 or I1 and I2 here. So when the torque is generated, whenever there is phi 1 and phi 2, two different fluxes has to be there, and that should be displaced with some angle. Then only torque is generated. Okay. If I take two same fluxes and the phase angle is not okay, it is in phase, then what is sine 0 here? Sine 0. Sine 0 is 0. Okay. Sine 0 is 0 here. Okay. Sine 0 is 0. Okay. So sine 0 is 0 here. So similarly, so what happens here when phi 1, phi 2 is there, because even though there is no phase shift, that the generated torque will be 0 here. Coming to single phase supply. Okay. Coming to single phase supply, what actually happens in single phase supply? In single phase supply, we'll see that. Okay, here how much which supply I'm giving here? I'm giving one phase, one neutral. Let it be some R phase and neutral here. So how many fluxes are generating here? Only single flux is generated. I need to be a little bit quick, and my handwriting, try to adjust with my handwriting, so that I need to complete entire thing in small amount of time. So we can able to generate only one flux is there. But what is torque condition here? What is torque condition here? Phi 1, phi 2 sine alpha. But just with a single flux, can you able to generate the torque? As per the formula, as per the condition, there is no. It's not satisfied here. Okay, na? So there is we cannot able to generate. But single phase supply will generate only single flux. Then, but in our homes, instead of single phase supply, can we use three phase supply? Is that possible? No. So just for the sake of using this motor, I cannot replace single phase supply with three phase supply. Okay, now I cannot replace. So only alternative is I need to do something in the motor, in the single phase motor, so that I can able to make use of that with the single phase supply itself. But what is my requirement? Torque is generated only when there is more than one flux is there. But I have only single phase supply. So in between the motor and the supply here, I need to do something such that the motor should be able to operate and torque should be able to generate. So what I am doing here, I am using the concept of split phase concept. Okay, I am using the split phase concept. So what I will try to do here, in the stator itself, I am creating two paths. In the stator itself, I am creating the two different paths here. One is resistive, other one is inductive or capacitive. Okay, so that what happens here, will there be, when I am creating two different paths here, so will it be providing separate phase shift between these two or not? I hope you know this. For resistance and inductance, capacitance. Okay, for resistance, if the voltage is, okay, what is the phase angle between voltage and current? If I am trying to draw the phase voltage here, what is the current phasor? Current phasor will be, this is in phase, current is 0, so phi equal to 0 degrees. Is that okay or not? For a pure inductor, let me try to say that pure inductor. Okay, so what is the current here? It is lagging by 90 degrees. Pure, I am saying that pure inductor. Okay, na? Pure inductor. Pure capacitor. So it is leading by 90 degrees. So obviously here phi equal to here 90 degrees lag and phi equal to 90 degrees lead here. Okay, so that means whenever I'm trying to use, if I use these three different combinations here, can I able to get the phase shift or not? Okay, I can able to get the phase shift. So what I'm trying to do here, in stator, I will try to go with the two paths here. In stator, I will try to add one more extra path here, so that I will try to insert this any one of the required component there, so that what happens here to the existing one, the phase shift is provided here. I will try to discuss in detail. Just I am trying to tell you that what actually happening in the single phase induction motor. If you see this fan, okay, if you see this fan, Yeah, have you ever seen a capacitor? Yes or no? Why? What's the purpose of capacitor here in fan? Even in the water pumps also. Okay. Without that capacitor, the fan or water pump won't work. What might be the reason? Because just now I discussed that this capacitor is providing an additional path. Okay, this capacitor is providing additional. Let's get back to the formula here. What is the formula here? Torque is proportional to phi 1 phi 2 sin alpha. Okay, here phi 1 is, I am saying that main flux, main single phase flux, main single phase or supply flux, main flux. Okay, and what about phi 2 here? This phi 2 is auxiliary or starting winding flux, auxiliary or starting winding flux. So I am trying to add a new path. So for this, what actually happens here? Okay, I am trying to add a new path here. For this, what actually happens here? This auxiliary winding or this starting winding will try to generate some flux here. Let it be, it can be resistance, it can be capacitor, and it can be inductance. If I add resistance, then phase to phase angle is, this phi 2 will be 0 degrees. If I add inductance, it is 90 degrees lagging. If I add capacitance, it is 90 degrees leading here. So basically, all these motors will be resistive nature or inductive nature or capacitive nature. Most in all machines, okay, inductive in nature. All machines are inductive in nature. So phi 1 will be lagging, inductive. Phi 1 flux is also inductive, that is lagging. Okay, and I will try to select phi 2. One time I will try to select resistive, other time I will try to select capacitive. Why I am not selecting inductance? Already the phi 1 itself is inductive in nature, because the machine itself, all the machines are inductive in nature. That's why because of the flux only the machine is we can able to generate the flux. Okay, so that what is the two other alternatives here? Resistance and capacitance. Okay, I hope you already know that the basic difference between practical inductor and practical capacitor. Practical inductance, practical L. What happens here? The phase angle will be between 0 degrees to 90 degrees. Practical capacitor, 0 degrees to 90 degrees leading. I mean, okay. So okay, let's get back to the concept here. Okay, so that's why I'm trying to call this concept as split phase induction motors. Okay, why the name is justified? Just now, previously I didn't tell that split phase. Once the topic is completed, now I'm justifying that. What is the title name here? Split phase induction motors. Why it is induction motors? Because induction motors, this induction, okay, single phase, split phase induction motors. Induction motors is nothing but we are using the concept of induction motors. Single phase is nothing but, what is the supply that I am using here? I am using a supply called single phase here. And what of the split phase here? For stator, I am adding one more winding, okay, that to generate phi 2. So then what happens here? Phi 1 flux, phi 2 fluxes will be generated here, and sin alpha will be generated here. Whenever, remember one more point here, if single flux is there, okay, if single flux is there, you might be in 3-phase induction motor, used to say that in 3-phase induction motors, we used to say one word, RMF. What is RMF? Rotating magnetic field. That's good. Okay, rotating magnetic field. Okay, rotating magnetic field here. Why it is called rotating magnetic field? Because I am giving a 3-phase supply. Okay, as 3-phase supply is given here, a combination of two fluxes will give us the rotating. The flux is rotating. Okay, now that's why it is called as rotating magnetic field. But whereas with single phase supply, okay, can I able to get the rotating magnetic field? No. With single phase supply, I can only get, it is like this one, phase, okay, voltage and time. Okay, I can able to get only alternating nature. I can able to get only the alternating nature. Okay, I can only get alternating nature, not rotating nature. In order to get the rotating nature, what should I do here? I need to add extra flux. That flux is called in that auxiliary flux. Okay, that flux is called as auxiliary flux. I hope it's clear. Okay, why there is a need of this phi 1, phi 2 and sine alpha. Okay. So, are you all already familiar with these topics? Yes. I'll conclude this split phase motors. One is resistance split phase, capacitor start, capacitor, two well capacitor. Directly important questions. Then we'll think about the others. Okay. So this is double field revolving theory. Okay. Double field revolving theory. What it concludes here? That means, so I'm splitting whatever the single phase supply is there. Single phase supply that will lead to flux. Single phase flux. This flux I am dividing into two components here. This main flux, okay, this main flux is divided. I am assuming that I am dividing into two components. One is phi 1 and phi 2, or else forward flux, backward flux. Okay, one flux is rotating in clockwise, another flux is rotating in counterclockwise. One flux is rotating in clockwise. Okay, what is this double field revolving theory? I am trying to justify that why single phase induction motor is not self-starting. Conclusion is, why single phase induction motor is not self-starting. Why single phase? Justify. The question will be like this. Okay, now everyone will prepare for only for the sake of external exams. What is the question will be? Justify why single phase induction motor is not self-starting. And others explain double field revolving theory also. You may get another also. But the answer, okay. So here we can able to say that. So here the flux, just to analyze it, we are considering that whatever the single phase supply flux is there, I am dividing that flux into two components. One component is rotating clockwise, other flux is rotating in counter clockwise here. So each flux will be phi f will be this one, phi f will be phi m by 2, and phi b will also be phi m by 2 here, and the total flux will be phi m here. Okay, so if you can see that I am trying to consider it for different positions here. Omega t equal to 0 degrees, omega t equal to 90 degrees, omega t equal to 30 to 45 degrees. Okay, for different positions here. It's at starting. Okay, it's starting. If I am trying to consider this one as A flux as well as B flux. Just know that phi f, phi b here. A flux is always rotates in counterclockwise. B flux rotates in clockwise. Okay, as which supply I am giving here? AC supply or DC supply to motor? Single phase supply. Single phase supply AC or DC? AC. So AC nature is, by default it is alternating here. So with respect to time it changes here. So let's assume that at omega t equal to 0 here, two fluxes are at starting position. The resultant flux is directly, it is arithmetic sum. What is the case here? You need to draw this diagram in the exam here. So the resultant flux is directly the arithmetic sum here. As because both are in the same direction. If it is in the different direction, then only the phasor concept will come here. Okay. So the resultant flux, phi resultant will be phi m by 2 plus phi m by 2. So resultant will be phi m here. Coming to this 32 to 40 degrees here, second case here. So slowly the A phasor is shifting, moving in the clockwise, and anti-clockwise, and B phasor is moving in the clockwise here. So here also what's actually happening here? So the resultant of phasor is this. You might have studied this pitch factor. It's vector sum by arithmetic sum here. 2e cos alpha by 2 by 2e. So similarly, you will get this 2 phi m by 2 into cos. What is the angle here? This angle here, cos alpha by 2 here. This is the resultant flux that we generate here. And at 90 degrees, what actually happens here? One flux is completely moving plus positive y-axis plus, as well as one other flux is moving to the y-axis negative here. What is the resultant flux of both are completely in which manner here? Phase opposition, yes or not? So only for machines, diagrams and keywords are most major important thing. Okay, phase opposition is there, as both are in completely in phase opposition or 180 degrees here. What is the resultant flux here? It's 0 degrees. It's 0 here. And coming to the other case here, similarly again it shifts here and here also. What are the condition is similar to this one. Again it will try to generate some resultant flux here. And again once it reaches to the negative case here, it's similar to this one. Okay, and both are in completely, now it is x minus case here. If you try to draw the graph here, it is x plus, x minus, y plus, y minus. Both again both two fluxes are again combining, reaching here, and it's like a arithmetic sum here. Again the resultant flux is also phi m, but that too it is in the negative side, negative axis, y minus or negative side here. So this process continues here, and we can able to see that we can able to generate the resultant flux in the sinusoidal manner. We can able to generate the resultant flux in the sinusoidal form, sinusoidal waveform here, because I am taking a sinusoidal waveform, I am dividing the flux into two components. Again the resultant for different positions. Okay, I am assuming that ultimately what I need to see that with the single phase apply, can I able to get the rotating magnetic field or not? That I am trying to see that. I am assuming that one is rotating clockwise, the other one is rotating in the anti-clockwise. I am from that I am making different combinations here, so that the resultant flux will be generating in terms of sine waveform here. Okay, so just now we discussed that we have two fluxes here. One is phi f, other one is phi b. Phi f is rotating in clockwise. Okay, if the let me try to be I will try to be little quick here. Okay, if this is the rotor and the outside one is the stator, I am just representing S and R here. Okay. Okay, and here the rotor is rotating in which direction? Rotor is rotating in the clockwise. Even the phi f flux is also rotating in clockwise. Okay, when phi f flux is also rotating in the clockwise, then rotor is also rotating in the clockwise, and as well as ns flux synchronous speed is also rotating in the clockwise. Okay, the RMF rotating magnetic field, the flux is. So here, can I able to find out the relative speed between this flux, forward flux as well as rotor? And we have the concept called slip. What is slip here? Which comes under three-phase induction motor. It is ns minus nr by ns. Okay, whatever the three-phase induction motor concepts are there, everything will come here also. Directly we can implement here. It is ns minus nr by ns here. As both are rotating in the clockwise here, okay, we can able to get the slip as positive, because ns will be more and nr will be less, so that we will get this slip will be positive here. We can say that SF, I can conclude that it is SF here. SF stands for forward slip, whereas in the backward slip, backward flux, for backward flux, what actually happens here? For backward flux, the rotor rotates in clockwise, but flux, what I am assuming that in real phi f and phi b fluxes are not there, but I am assuming here phi f flux I am assuming that is rotating in the clockwise, phi b flux which I am rotating in the anti-clockwise. When phi b flux is assumed which is rotating in the counter-clockwise or anti-clockwise here, both are opposite or not? Okay, both are opposite. If I say that from this college point, if I ask two persons to use the bikes and go in the same direction, okay, one with 50 kilometers per hour and another with 40 kilometers per hour, what is the relative speed if I ask you? Then relative distance or relative speed, it will be 50 minus 40, that is equal to 10. If I ask two persons moving in the opposite direction, okay, let's say that there are two routes here, one is towards the front and the other is backward here. Okay, now the distance increases or decreases? Increases. Okay, the same happens with the counterclockwise also. The speed is here, it is the rotor speed is okay, somewhere at 1400 rpm, and this phi b flux is rotating at 1500 rpm. What is the relative speed now? It is 1500 plus 1400. Previously, if I assume that it is 1500, synchronous phi f flux is 1500 rpm, rotor is rotating at 1400 rpm. If I ask you that relative speed, what should I do here? Add or subtract? subtract 1500 minus 1400, that is equal to 100 is a relative speed here, ns minus nr here, and that's why I am keeping this negative sign. I hope you understood why I am keeping negative sign. Slip formula remains same, but for backward flux it is counterclockwise. As it is in counterclockwise compared to this clockwise case here, I am using the negative sign. That is ns minus of minus, that will be ns plus. So 1 plus, if I split this, it will be 1 plus n by ns here. We have the formula here, s equal to ns minus nr by ns. S into ns, if I use this, s into ns equal to ns minus nr. If I rewrite this, okay, I'll shift this nr here, okay, nr equal to, okay, nr and ns minus ns. So here next nr by, if I take ns common here, 1 minus s. Am I getting this formula or not? Okay, take this ns common here, then what happens here, ns, it will be ns into 1 minus s here. So nr by ns equal to 1 minus s here. Okay, so instead of this n also considered as nr here. Instead of this n by ns, I am considering here it is 1 minus s here. So 1 plus 1 minus s, what is the value here? 2 minus s. You might have written this E set and other things here. Okay, na? So competitive exams for sub-engineers, so many times they will ask these concepts. So what is the backward slip formula? S, 2 minus s, 1 minus s, and none of the above. The answer should be 2 minus s. How you got here? Simply use the slip formula and try to add minus of minus, that will be plus, and use the nr formula, nr equal to ns into 1 minus s. So this is how I can able to get the forward slip as well as backward slip. Why am I all doing this? So yeah, let's try to discuss here. I hope you already know the relation between air gap power, copper losses, as well as output power in 3-phase induction motor. The ratio between 1 is to s is to 1 minus s. Have you heard this? Yes or no? 1 is to s is to 1 minus s. This is the ratio between the, what is P2 here? P2 is nothing but rotor input power. P2 is nothing but rotor input power. PCU is nothing but rotor copper losses. P out is nothing but mechanical output. If you have the induction motor basics, it is dead easy. Okay, if you have the induction motor basics, it's dead easy. Again, I cannot get back and what is the ratio between 1 is to s is to 1 minus, again it will take half an hour. Okay, so that's why 3-phase induction motor unit is first and then it is followed at the last. Okay, so as the name is induction motor, what are the concepts that we use? Even the equivalent circuit also will try to make use of the same here. Okay, so rotor input power. So here we have the formula here. So I can able to get the relation here. So mechanical power by equal to, we can able to get this formula here. That is 1 minus s into I2 square into R2. Okay, 1 minus s. Okay, we'll try to write down we'll try to get the relation here. Okay, between the any two powers we can able to get that. If I want to get P2 is to P copper, then what is the formula here? That is 1 is to s. Okay, 1 is to s here. We can also write down this. If you want me to tell, I can also tell this. P into PC into P out. We can able to get 3 into I2 square into R2 by s. 3 into I2 square into R2. 3 into I2 square into R2. 1 minus s by s. I hope even you remember this formula. You know this formula. 3 into I2 square into R2 by s. 3 into I2 square into R2. Simple copper losses formula is what? I2 square into R2. As it is 3-phase, I am using 3 here. So and rotor air gap power, that is divided by s, and rotor output, mechanical output power 3 into I2 square into R2 into 1 minus s by s here. This is how, and from that we'll try to get this conclusion here. 1 is to s is to 1 minus s. So this is for 3-phase induction motor. This is for 3-phase induction motor. What I will try to do here, I will try to use this formula. I will try to use this formula for single phase induction motor. Okay, finally I want torque. In order to get the torque, first I need to get the power. I need to get the power here. So what is the power for single phase here? That is 1 minus s into s by I2 square into R2. I am not including 3. Why? Because why I am not including 3 here? Because it's not a 3-phase supply. If I use three phase supply, then I need to multiply with 3. Otherwise, single phase supply, let's ignore this 3 here. So we got this PM, mechanical power, gross mechanical power, that is equal to 1 minus S into S by I2 square into R2. And we know this formula, P equal to omega T. What is power equal to? The relation between power and torque. P equal to omega T, which is also say that 2 pi N by 60 into torque. So rewrite that, and I need to get the torque here. Torque equal to P by omega. So that is equal to 1 by 2 pi N. And we have this NR. What is the formula for NR? Just now we discussed that in the previous slide. NR equal to NS into 1 minus S. So NR equal to NS into 1 minus S. Okay. NR equal to NS into 1 minus S. Okay. Okay. So NR equal to NS into 1 minus S. By substituting this and cancelling these terms, we can able to get the constant. What is K here? 1 by 2 pi NS. So we'll try to get this torque. Okay. We'll try to calculate the torque in both cases here, forward as well as backward here. So for forward, I'll try to get this formula here. TF equal to K into I2 square into R2 by S here. For backward case, instead of wherever we use S, what should you do here? Instead of S, we have to replace it with 2 minus S. Just now we discussed in the last slide itself why we are getting 2 minus S. So for forward in general we use S. For backward slip we need to use 2 minus S. We got the forward torque as well as backward torque. What is the resultant torque at any instant? TF plus TB. Suppose when speed is equal to 0, when rotor speed is equal to 0, then what is the slip? I guess everyone will answer this. Slip is equal to 1. I guess there is no need to again explain this. When speed is equal to slip equal to 1. If you substitute this value S equal to 1 in the forward as well as backward, then what happens here? So S will be 1 here, and it is 2 minus 1 equal to yes. Okay, yeah. So if I substitute S equal to 1, then what happens here? Both forward torque as well as backward torque, both will be equal. The resultant torque will be 0. Why I am keeping minus here? It is opposite. As it is opposite, I am keeping it as minus here. So there is forward torque as well as backward torque at what instant? When n equal to 0, that is when S equal to 1. So, and we'll try to see this. This is the resultant torque versus speed here. This one is okay. The above one, the dotted above one is forward torque. The above dotted one is forward torque, and this below one is backward torque. And this total one, the thick line which I am representing, that this is resultant torque. What is resultant torque? TF plus TB. Resultant torque is TF plus TB here. What we see that when speed is equal to 0, what is the slip? S equal to 1. When S equal to 1, just now we concluded that what is the torque? 0. So when the motor is about to start, what is the torque that is available here? 0. When torque is 0, is there any possibility for the motor to rotate? Okay, is there any chance? No mechanical power, so the motor will not rotate here. That means if with single phase supply, we will get the flux. The nature of the flux is just alternating. It's not rotating. Though we assume that I assume that two fluxes are there, and I have divided the two fluxes. One is rotating clockwise, the other one is anti-clockwise. Still, it's not happening the same manner. Still the torque will be 0. Can I conclude that with single phase supply the generated torque will be 0 or not? How I am justifying? I am justifying by using the concept called double field revolving theory. Why when heading should be discussed? It should be discussed at the end of the topic, not at the start. Then only you can able to justify why it is called double field. I guess we can able to answer this. We are indirectly using two fluxes. One is forward flux, other one is backward flux. As I'm using the two different fluxes, forward flux as well as backward flux here, that's why it is called as double field revolving theory. What this double field revolving theory states? It states that this single phase induction motor with single phase supply, we cannot able to generate the torque. Even if you assume the two different flux components, the resultant torque at any instant will be 0. Okay, the resultant torque at any instant will be 0. This you can get for 10 marks question. Okay.